Today we will study P groups. This is algebra class, and the topic is P groups. ये P ग्रुप क्या होता है, इसके बारे में बात करेंगे आज हम लोग. सो इसकी डेफिनेशन देखते हैं. डेफिनेशन डेफिनेशन क्या कहती है इसकी? लेट P बी अ प्राइम. लेट P बी ए प्राइम नंबर. A group G is said to be P group if every element every element of G as order P raised to power K, where K belongs to integer, right? So इसका मतलब क्या है, मीनिंग क्या है इसका? मीनिंग क्या है इसका? कि कोई जी ग्रुप है, वो पी ग्रुप कहेंगे हम लोग अगर कोई ए बिलोंग्स टू एनी ए बिलोंग्स टू जी, implies order of that A is P raised to power K, where K belongs to integer. अगर कोई भी एलिमेंट लेंगे जी का, उसको हम P की पावर में, P क्या है, प्राइम है, P इज प्राइम, P की पावर में लिख सके. हर एक एलिमेंट का ऑर्डर जो है जी का, उसको P की पावर में लिख सके. तो ऐसा जो ग्रुप होता है उसको बोलते हैं P ग्रुप. कहने का मतलब, लेट मी डू इट अगेन. अगर कोई जी ग्रुप है, इसको कहेंगे P ग्रुप, वेर P इज प्राइम फॉर ऑल ए बिलोंग्स टू जी. अगर ऑर्डर ऑफ ए जो होगा उसको हम पी रेज टू पावर समथिंग लिख सकें, वेर के बिलोंग्स टू जेड. अगर कोई किसी भी एलिमेंट का ऑर्डर पी रेज टू पावर समथिंग लिखें, तो ऐसे एलिमेंट को हम लोग ऐसे ग्रुप को बोलते हैं पी ग्रुप. एग्जाम्पल लेते हैं इसकी. फॉर एग्जाम्पल, लेट जी इज इक्वल टू लेट जी इज इक्वल टू ए. A cyclic group of be a cyclic group of order P raised to power K. Now, where P is prime and K is integer. So in this group, any element, so we know that in cyclic group, what happens? Order of G is equal to order of generator. Okay. So order of generator क्या होगा आपका? P raised to power K. So every element now, so what we got? Order of G is equal to order of A is equal to Pk, and G is generated by A. So any element, let X belongs to G, any element of G, this will give you X is equal to A raised to power say R, where R belongs to Z. क्योंकि ये जनरेटर है इसका, तो X को हम लोग A raised to power R लिख सकते हैं. So इसका मतलब ऑर्डर ऑफ जो X होगा, this is equal to order of A raised to power R, and this is a power of P. This is a power of P then. Okay. So say power of P means, say some S, where S belongs to Z. So this means that every element of X, therefore, so every element of G, here order of X is a power of some S, where S belongs to Z. This means that G is a P group because every element is of order P raised to power something. So we can say that it's a P group. Also, we know that cyclic group is abelian group, is abelian. This means that G is a abelian P group. Fine. तो कोई भी साइक्लिक ग्रुप होगा जिसका ऑर्डर P की रेस्ट पावर K होगा, वो क्या होगा? P ग्रुप होगा. दिस इज अ वेरी इंटरेस्टिंग एग्जांपल, वेरी जनरल एग्जांपल एक्चुअली. कोई भी ग्रुप होगा जिसका ऑर्डर P रेस्ट पावर K होगा, दैट इज ए दैट इज ए P group. Second example, let's take second example. Example 2. Let us take quaternion group. Quaternion group. Quaternion group is this Q8 is equal to plus minus 1 plus minus I plus minus J plus minus K. This is what it is. Now it satisfies some properties. Properties can satisfy karta hai. I square is equal to J square is equal to K square is equal to minus 1. And this is triad I J K. So I into J is equal to K, and JK is equal to I, and KI is equal to J. Further, uh, IK is equal to minus J, and KJ is equal to minus I, and JI is equal to minus K. So these are the properties. This is satisfied by this Q8 group. Now we have to see whether a this is a P group or not. Let us see. Now we have to find out order of each element. So first of all, we start with order of 1. Order of 1 is 1, identity element. Order is 1. Order of minus 1, this can be written as order of 2 is, this is 1, this is identity element. So order of minus 1 is 2. That is 2 raised to power 1. This is a power of prime. Again, iota square, this is equal to minus 1. This means that I की 4 power, this is 1. This means that order of I is equal to 4. That is 2 raised to power 2. That is again a power of a prime. And minus iota square, this is going to be minus 1. Then minus iota ka 4 power, this is going to be same 1. So this means that order of minus iota, this is equal to 4. This is, let us go to other page, next page. Minus iota ka 4 power, this is equal to 1. This means that order of minus iota is equal to 4, and this is 2 raised to power 2, where 2 is a prime raised to power something, right? Again, similarly, you can see that plus minus J is order of plus minus J is 4, and order of plus minus K is 4. So all the orders we are writing, all the elements, they are having the order 2 raised to power 2. That is, therefore, all the elements of Q8, all the elements of Q8 are of order is equal to power of 2. 2 is prime. That is prime. Power of 2, that is prime. Fine. So this means every element of Q8 whose order is a power of prime. So we can say that Q8 is what? Is a 2 group or P group or 2 group. Fine. Further, of order, we know that order of Q8 is 8, order 8. Moreover, we have seen that Ik is not equal to Ik is equal to minus I minus j, and Ki is equal to j. So Ik is not equal to Ki. So this means that non-commutative group. Fine. Non-commutative group. That is non-abelian. So we see that this means that Q8 is a non-abelian 2 group. That is P, basically P की value यहाँ पे 2 है, 2 group of order 8. This is the finest example. If you can understand a non-abelian group which is 2 group. Here is a 2 group because here P is equal to 2. Every element of G is order of every element of Q8 is expressed as a power of 2. That is expressed as a power of 2. Either this is 2 or 2 का square. Fine. So this is how we write this P group. Let us understand a little more. An example. One more example. Clean group. We will talk about clean group. Clean group. You know that clean group is. We will talk about clean group of this Sn. So S3 basically we will talk about S3. So clean group, we can take K4 is equal to I 1, 2, 3, 4 and 1, 2, 1, 2, 3, 4. This is a group. This is a clean group. You know that clean groups की properties क्या होती हैं? K4 is equal to E, A, B, C, where A square is equal to E, B square is equal to E, and AB is equal to C, AC is equal to B, and BC is equal to A. So these are the examples of this. This is a basic structure of clean group. So as we are talking about the S4 structure, we will see here how this is going to work. So let us see. Now we can see the power of this 1, 2. This permutation, power of this, and this is going to be 1, 2, 1, 2, and you know that how to calculate this because this is on uh, three symbols. This is 1 goes to 2, 2 goes to 1, and 3 goes to 3. Sorry, 3, 4. 4 symbol. This is as 4. 1 goes to 2, 2 goes to 1, 3, 4 as it is, and 1 goes to 2, 2 goes to 1, 3, 4, 3, 4 as it is. Either you can write this way. शॉर्टकट बताऊंगा वैसे भी आप कर सकते हो. So 1 goes to 2. So here 1 goes to 2, 1 goes to 2, and 2 goes to 1. 1, 2, 3, 4. 1 goes to 2, 2 goes to 1. This is 1. 2 goes to 1, 1 goes to 2. This is 2. 3 already goes to 3, and 4 goes to 4. And this is nothing but identity. So we say that order of 1, 2, order of the permutation 1, 2 is equal to 2. This is the power of 2. Again, similarly, order of 3, 4 is equal to 2. This is again power of prime, 2 raised to power 1. and order of 1, 2, 3, 4. This is also equal to 2. So, so all are of order 2. Fine. So this is how we are seeing that all the powers of 2. So and so we are getting what? So we have, so therefore K4 is a 2 group because prime is here, prime here, prime is here 2. So this is a 2 group, right? It's a 2 group. Moreover, K4 is abelian. Therefore, K4 is 2 group which is abelian. Fine. और furthermore you can say that K4 क्या चीज है? एक abelian group है which is 2 group and of order 4. So this is how we can see that this K4 is a 4 group, K4 is a 2 group क्योंकि हर एक एलिमेंट क्या है? हर एक एलिमेंट का ऑर्डर क्या है? 2 है. So 2 raised to power something. So 2 is a prime number. So that's why it is called P group, right? This is how we find this. So next we will do, next we will see. Now there is an account, there is an example of a group which is not P group, which is not P group. Let's see an example of a group which is not P group. Fine. So let us see that. We know that S3 is equal to I 1 2 1 3 2 3 1 2 3 1 3 2. This is what it is. So we have got this group, and we know that order of 1 2 is what? Just found order of 1 2. 1 2 is 2 because 1 2 ka square. This is going to be 1 2 1 2, and this is going to come as 1 goes to 2 and 2 goes to 1. So 1 goes to 1, 1 goes to 2, 2 goes to 1. Similarly, 2 goes to 1 and 1 goes to 2. And so, and as it is 3, and this is going to come as, sorry, this is how we do this. This is going to be identity element because uh, let me do it properly. 1 2 3 4 2 1 3 4 because these are 2 cycles. 1 2 3 4 2 1 3 4. You can write this way. 1 2 3 4. So 1 goes to 2 and 2 goes to 1. So this is 1. 2 goes to 1 and 1 goes to 2. This is 2. 3 already goes to 3. 4 goes to 4. This is identity element. So order of 1 2 is 2. Similarly, order of 1 3 is equal to 2. Order of 2 3 is equal to 2. But order of 1 2 3 is 3. So all the elements are not the power of 2. So similarly, order of 1 3 2 is equal to 3. So all elements don't have order is equal to power of 2 or 3 only. So all the इन सब की एक प्राइम की पावर नहीं है सारे, इसलिए दिस इज नॉट, सो देयरफॉर S3 is not a P group. Okay. P group means neither two group nor three group, because there are few elements which are of two order, there are few elements who are three order, so they are not the powers of the same prime, so that's why this is not a P group. So these are the few of the examples to understand what is the meaning of P group. So now we will do a theorem on P group, how the elements of P group are characterized. Theorem's statement is, theorem says let G be a finite group, G is a P group if and only if order of G is equal to P. If the order of G is P raised to power K, then we say that this is a P group. So by definition, every element is going to have the same, have some power of, have order that is equal to power of some prime. Now here we are showing order of G is exactly P raised to power K. If this is happening, then we say that P is a P group. Sorry, G is a P group. We can see an example. For example, we see Q8. So Q8 group, order of Q8 is what? Is 2 raised to power 3. That is, let me write properly. This is 8. This is 2 raised to power 3. So this is the order of this, right? Now we are writing order of G in terms of P raised to power something. P is equal to 2 and K is equal to 3. So we are writing 2 raised to power 3. This is the order of Q8. This implies that Q8 is nothing but 2 group. Fine. Same is the case for K4 also. Order of K4 is 4, and that is equal to 2 raised to power 2, where P is equal to 2 and K is equal to 2. This means K4 is a 2 group. Fine. This is how we can see this theorem. Now we will prove this theorem. Let's talk about the proof. Let's see the proof. There are two way to prove this, directly as well as conversely. So firstly we will do directly. Let करते हैं. Let G be a P group. Now G is a P group. So this means that by definition of P group, every element A belongs to G as the order of A is equal to P raised to power some K, where K belongs to integer. Right? This is what it is. Now we are seeing that यहाँ पे हमने देखा कि एक एलिमेंट का ऑर्डर P raised to power K है, तो हम लोग इसको क्या करेंगे, प्रूव करेंगे बाय यूजिंग कॉन्ट्रडिक्शन. तो देखते हैं जरा, क्या कोई और प्राइम जो है वो इस एलिमेंट का ऑर्डर बन सकता है. तो वी विल प्रूव दिस बाय कॉन्ट्रडिक्शन मेथड. ओके. सो कैसे प्रूव करेंगे? लेट करते हैं, लेट Q बी अदर प्राइम which is different from from P. That is, Q is not equal to P. Fine. Say that Q divides order of G. Q divides order of G. Now, we know by Cauchy's theorem. By Cauchy's theorem, we by Cauchy's theorem. Cauchy theorem क्या कहती है? Theorem says G is finite, finite order, finite group. Q divides order of G implies there exists an element A in G such that order of A is equal to Q. Order of A is equal to Q. So from this, let it be 1, let it be 2. From 1 and 2, from 1 and 2, what happens? Q is equal to P raised to power K. Now, P is prime, Q is prime. So they don't have any common factor. This means this is possible if and only if Q is equal to P. और तो कोई पॉसिबिलिटी है ही नहीं. कभी हम किसी भी प्राइम को ऐसे नहीं लिख पाएंगे. जे मतलब ये दोनों प्राइम अलग अलग हैं. तो पी रेस्ट टू पावर समथिंग के है, तो इस प्राइम को मैंने ऐसे लिखा, तो प्राइम को मैं इस फॉर्म में नहीं लिख सकता हूँ. सो दिस मीन्स दैट दिस इज पॉसिबल इफ क्यू इज इक्वल टू पी. तो दिस इज ए कॉन्ट्राडिक्शन, बिकॉज हमने क्या लिया था? हमने क्या लिया यहाँ पे हमने क्यू इज नॉट इक्वल टू पी लिया हुआ. तो यहाँ से कॉन्ट्राडिक्शन आ गई. तो इसका मतलब क्या हो गया? सो देयर इज ओनली वन पी. सो देयर इज only one prime P so that P divides order of G. और कोई प्राइम ना इसको डिवाइड नहीं कर सकता. कोई भी डिवाइड करेगा वो इसी के बराबर आ जाएगा. सो हम लोगों को क्या मिलेगा? यही डिवाइड करेगा. अगर यही डिवाइड कर रहा है, ये P डिवाइड कर रहा है ऑर्डर को, इसका मतलब ऑर्डर ऑफ G जो हो जाएगा वो क्या हो जाएगा? P रेस्ट पावर समथिंग. क्योंकि ये इसको डिवाइड करेगा तो ऑर्डर ऑफ G क्या हो सकता है? P रेस्ट पावर K हो सकता है. P रेस्ट पावर K where K belongs to integer. So we have proved that if G is a P group, this is a P group, then its order is bound to be P raised to power Q. Now we will prove conversely. Let order of G is equal to P raised to power K. Fine. If order of G is equal to K, let A belongs to G, then order of A raised to power order of G, A raised to power order of G, this is equal to E. We know that if A belongs to G and order of G is equal to N, then we know that A raised to power N is always equal to E. This is theorem. Fine. So this is what we are using. So this is equal to this. This means also one more theorem is एक और रिजल्ट है हमारे पास. अगर A raised to power, अगर G का ऑर्डर क्या है? ऑर्डर ऑफ G क्या है? N है. और A belongs to G है. A का ऑर्डर क्या है? M है. A का ऑर्डर M है. Then M divides N. That is order of A divides order of G. So this is what it is. तो यहां से हम लोग ये लिख सकते हैं order of A divides order of G. This means that order of A divides P raised to power K. This is the order P raised to power K. If we are writing P raised to power K, this means that order of A is equal to some power of P. This is a some power of P for all A belongs to G. जितने भी होंगे A इसमें वो सबके लिए होल्ड करेगा. तो इसका मतलब क्या हो गया? एवरी एलिमेंट ऑफ G. दिस मीन्स दैट फॉर ऑल A belongs to G, order of A is some power of prime p। किसी p की प्राइम की ये पावर है, तो इसका मतलब क्या होगा, हर एक एलिमेंट का क्या पावर है, प्राइम की p की पावर समथिंग है ऑर्डर उसका। इसका मतलब जी क्या हो गया, जी इज ए पी ग्रुप। तो हमने प्रूव कर दिया कि जी क्या हो गया, पी ग्रुप हो गया। दिस इज वेरी इंपॉर्टेंट रिजल्ट टू करेक्टराइज ए पी ग्रुप। तो हम लोग सिंपली क्या करेंगे, कोई भी हमारे पास अगर पी ग्रुप हमें देखना है कि ये पी ग्रुप है कि नहीं है, हमने उसका ऑर्डर देखना है। अगर उसका ऑर्डर पी रेस्ट टू पावर के होगा, इस फॉर्म में अगर हम लिख सकते हैं और ये फाइनाइट ग्रुप है, तो हम लोग सीधा सीधा लिख देंगे कि वो क्या है, पी ग्रुप है। एक और एग्जांपल करते हैं, हमारे पास एक बड़ी अच्छी एग्जांपल है, डाईहाइड्रल ग्रुप। डाईहाइड्रल ग्रुप डाईहाइड्रल ग्रुप कैसे लिखते हैं हम लोग, ये रहता है हमारे पास D4 बोलते हैं इसको, एंड दिस इज ई ए स्क्वेयर, ए का क्यूब, देन बी, देन बी ए, देन बी ए स्क्वेयर, देन बी ए क्यूब। इट सेटिस्फाई द प्रॉपर्टीज। इसकी कुछ प्रॉपर्टीज हैं, ए की 4 इज ऑलवेज ई, एंड बी स्क्वेयर इज ऑलवेज ई, एंड ए बी इज इक्वल टू बी ए इनवर्स, and these are the properties. Now we will check the order of each of the element. So let's see order of A. Let's see order of A. Order of A. A का 4 करेंगे तो हमको E मिल रहा है। इसका मतलब order of A is equal to 4, and this is nothing but 2 raised to power something. So this is a 2 raised to power prime power something. Similarly, order of A square की बात कर लेते हैं। A का स्क्वायर करें तो क्या आता है हमारे पास, सॉरी A का स्क्वायर, एंड दिस raised to power 2 कर देते हैं इसको। So this is going to be A4 and this is going to be E. Therefore, order of A is equal to 2. A square is equal to 2. This is again a power of 2. Similarly, order of A का 3 power, ये देखते हैं क्या है, order of 3 raised to power 4. This is equal to A raised to power 12, and this is going to come as A raised to power 4 3, and this is going to come as e raised to power 3 is equal to e. This means that order of a की 3 is equal to 4, and this is again 2 raised to power something, so again a prime raised to power something. Similarly, we can talk about order of b. This is equal to, this is going to come as uh, because this is 2 here, order of b is equal to 2. Similar to this, now we will find order of BA. Let's see how it is found. Now BA ka square, let's see what happens. BA is equal to BA. Now associativity can used here. BA AB is equal to this. Now we know the property AB is equal to this, AB is equal to BA inverse. So we can write here B, this is going to be BA inverse, BA inverse A, and this is come to as B square, A inverse A, and this is going to come as B square E, and you know that B square is nothing but E, so this comes to be E. This means that order of B of A is again 2 raised to power something, 2 raised to power 1, fine. Similarly, order of B A square, you can find out, is equal to 2, and order of B A cube, this is equal to 2 again. So these are all the powers of 2. So every element of, so therefore, every element of D4 has order equal to power of 2. Power of 2. This means that D4 is a 2 group. Is a 2 group. Furthermore, by using the theorem, अब हम लोग यूज करते हैं थ्योरम को. Now D4 का जो ऑर्डर है वो क्या है? 2 into 4, that is 8, and this can be written as 2 raised to power 3. When we are writing 2 raised to power 3, so order of this is 2 raised to power 3, that is P is equal to 2 and K is equal to 3. This means that D4 is a 2 group, right? By using theorem. अभी हमने थ्योरम की कि जो ग्रुप है, अगर G कोई फाइनाइट ग्रुप है, then G is P group if and only if ऑर्डर ऑफ G को हम किस तरह लिख सकें? P रेज टू पावर K लिख सकते हैं. K रेज बिलोंग्स टू इंटीजर. अगर ऐसा लिख सकें तो हम लोग क्या कहेंगे इसको? दिस इज द P ग्रुप. तो अप्लाइंग दिस वी कैन सी दैट D4 is a group. Further, D4 is non-abelian. This we know that this is non-abelian. You can see also this is a non-abelian. So this means that D4 is a non-abelian 2 group of order 8. So this completes your P group. Hopefully, this much knowledge will be helpful for your preparation. And furthermore, this is going to be handy in understanding the definition of P group. So I'll stop here. Thank you.